In today's video, we are going to learn about the difference of two squares. It's a very straightforward and a pretty simple concept, so make sure to stay tuned and then follow very keenly, and you're going to understand this. Okay, so if you talk about the difference of two squares, we mainly use an expression to represent the difference of two squares, and the expression is a squared minus b squared. Now this is just a general expression representing the difference of two squares. Okay, so what is this difference of two squares, and why the name difference of two squares in the first place? So I mean, difference basically means subtraction, right? And two squares, um, meaning that we are dealing with two squares basically. Okay, so we are dealing with this first squared, which is a squared, and then this is another square, which is b squared. So basically, we are dealing with two squares, and then we are finding the difference of those two squares. So hence the name difference of two squares. Okay. Um, Now you probably know this already, but just so we can just recap. A squared means a times a, and then b squared means b times b. Okay. So we are going to apply this to solve this example. So let's say you are given this problem to solve. We have 4 squared minus 2 squared. Using the interpretation we have from the previous slide, we can calculate 4 squared as 4 times 4. That's going to give us 16. And then we can calculate 2 squared as 2 times 2, and that's going to give us 4. Okay, so basically 4 squared minus 2 squared is just the same thing as 16 minus 4. Okay, so 4 squared here is 16, and then this 2 squared is 4. So we just replace them with their values. That's going to give us 12. Okay, similarly, if we have 5 squared minus 4 squared, um, that is also pretty straightforward. Okay, 5 squared is the same thing as 5 times 5. 4 squared is the same thing as 4 times 4. And he subtracted 2. Okay, 5 times 5 is 25. 4 times 4 is 16. So we end up having 25 minus 16, and that's going to give us 9. Okay. How about these examples? So you can pause the video over here and then try and go through these examples using the method we've just um, established. Okay. You can pause the video and try. But these are the answers for um, these questions as well. Basically, for example, if you take the second example, 7 squared minus 5 squared is the same thing as 49. So 7 squared is 7 times 7, that's 49. 5 squared is 25. So basically, you're going to have 49 minus 27, and that's going to give you 24. Okay. So if you're able to do this, well done. Okay. Now, how about these examples? Okay. This is 34 squared minus 14 squared. How about this? Also, how about this particular example, or how about this example? Okay, now you can try solving these using the method we've just used to solve the previous examples, but you may probably run out into a challenge over here. Okay, the reason is that for these particular examples, whereby you are using two-digit numbers, the squares of those two numbers may actually be too big for you to calculate, especially if you're not using a calculator. Okay, so for example, finding the square of 34, that is like 34 times 34. Okay, that's going to give like a huge number. Same thing applies to, let's say, 49 squared or 36 squared or even 19 squared. Okay, so because we may run up into problems like finding the squares of bigger numbers, we apply a different uh, principle, sort of. Okay, and that is where we bring in the principle of the difference of two squares. So the examples we've solved previously is still difference of two squares, just that there is a natural principle governing difference of two squares, which make questions about difference of two squares quite easier to solve compared to using the first method we did. Okay, so and there's nothing scary about it. If you remember our first expression, which is a squared minus b squared, okay, this is just a general expression for the difference of two squares. Okay, it could be x squared minus y squared, or f squared minus h squared. It doesn't really matter, just that we usually use a and b to represent the two numbers. Okay, so um, this expression, which is the a squared minus b squared, can be expressed or put in a different form, or in another form, basically. So a squared minus b squared, per the principle of difference of two squares, is the same thing as a plus b in one bracket, then multiplying a minus b in another bracket. Okay, so we can use this to solve the previous examples we've already gone through, just to show that this method actually works. So if you remember this from the first example that we solved, we can also solve this using this formula above. Okay, so basically this formula is telling us that if you have first number squared minus the second number squared, is the same thing as adding the two numbers and then also subtracting the two numbers, then you add the two results that you got. Sorry, you multiply. It's not adding, you multiply. So you add a to b, then you subtract b from a, then you multiply the results you get. Okay, so we are going to use that to solve this particular question. So if you have 4 squared minus 2 squared, if you add 4 plus 2 in one bracket, so this is it, and then you subtract 2 from 4, that's also in another bracket. Okay, 4 plus 2 is 6, 4 minus 2 is 2, so you end up having 6 and 2 in separate brackets, which is the same thing as 6 times 2, and 6 times 2 is 12, and this is the same thing as what we had in um, the previous slides when we were solving this using the first method that we came across. Okay, similarly we can use it to solve the second example, okay, where we had 5 squared minus 4 squared, so that will be 5 plus 4 as we have it in the first bracket, then another bracket with 5 minus 4. Okay, 5 plus 4 is 9, 5 minus 4 is 1, so that's going to give us 9 times 1, and our final answer is 1, which is also same as the first method, using the first method to solve this. Okay, so similarly we can use it to try these examples as well. Again, you can pause the video and um, try these examples if you want, but using the formula we've just established, um, these are some of the answers we are going to get. So for the first one, 4 squared minus 3 squared is going to give us 4 plus 3 in one bracket, 4 minus 3 in another bracket. 4 plus 3 is 7, 4 minus 3 is 1, 7 times 1 is 7. Pretty straightforward and easy, right? And same thing applies to the other two examples as well. Okay, so just to go through the three examples, uh, we couldn't use the first method to solve. I mean, we can use the first method to solve, just that we want to make things easier for ourselves. Okay, so the first example was 34 squared minus 14 squared. Okay, so using the formula we've established on the principle we now know about, that's going to be 34 plus 14 in one bracket, 34 minus 14 in another bracket. 34 plus 14 is 48, and then 34 minus 12 is 20. So this is the same thing as 48 times 20, that's going to give you 960. Again, you can try this with the first method, and that will work perfectly as well. Just that you will probably end up having huge figures, which will make your work maybe a bit difficult compared to using this simple formula or method. Okay. Same thing applies to this one, so that's going to give us 19 plus 15 in one bracket, 19 minus 15 in another bracket. It's going to give us 34 times 4, and that's going to give us 136. Okay, then the last example, which is 49 plus 36, 49 minus 36, both in separate brackets. That's going to give us 85 times 13, and that's going to give us 1105 is our final answer. So this is where we bring today's video to an end. In the next video, we'll be looking at applications of difference of two squares, where we apply this method in other areas as well. Okay, so yeah, that will be all for now. Thanks for watching. I'll see you in my next video. Do not subscribe for more and leave your questions and contributions in the comment section. Till we meet again, peace be unto you.